Okay, it's time for part two. Now, today we are solving equations with variables and rational exponents. In other words, the variables are going to be in the exponent at times, or maybe the exponent's like a fraction or a decimal or something fun like that. So let's try this first one. Solve for x. That's all it means. Now, just to remember, solving for x, like if you had 4x equals 32, you would just divide by 4, boom, x equals 8. Done, finished. That's all solving for x means. Well, similarly, do this one the same. Divide by 4, you get 8 when you divide both sides by 4. Now, how do you solve this for x? Now this one's tricky. Now, if x has the first power to it, well, that's pretty easy. You're done. But we don't have the first power. We have the 3/2 power. But is there a way to make it so that we do have the first power? Now remember what you do, guys. When you have a power to a power, you multiply the powers. Question, guys. 3/2 times what equals 1? 3/2 times what? Well, 3/2 times 2/3 equals 1 because they're reciprocals. Wait a minute, what did I just say? Oh, they're reciprocals. That makes sense. So what you can do here is raise both sides of the equation to the same power. Well, how did that help you? A power to a power means you multiply. And as we said earlier, 3/2 times 2/3, well, that's just x to the first power. And now I have 8 to the 2/3 power. Well, there's a couple different ways you can handle that. Rewrite it in radical form. That's really just the cube root of 8 squared, which is the cube root of 64, which is 4. Or you could have done the cube root of 8, the whole thing squared, which is 2 squared, which is also 4. Either one of those options work. And that's it. If you want, you can check it by plugging it back in. Dum dum. So 4 times 4 to the 3/2 equals 32. Well, that's really 4 times the square root of 4 cubed. Well, the square root of 4 is just 2 cubed. That's 4 times 8. 32 equals 32. Cha-ching! That's it. Nicely done. Okay, let's kick it up a notch. Now here I have x minus 1, the quantity to the negative 1/4 power, is minus 2 equals 0. So what I would do is add the 2 to both sides. So it's really x minus 1 to the negative 1/4 power equals positive 2. Sweet. All right. But I don't have a first power, so it's not that easy. But how could I make it so that there is a first power? Oh, I could do my new approach. I could raise it to a power that makes it 1. I want to end up with just x minus 1. That's all I want to end up with. Well, what times what would give me 1? What times negative 1/4 would give me 1? What if I raise it to the negative 4 power? What's negative 1/4 times negative 4? Well, it's 1. So do 2 to the negative 4th. Oh, that makes sense. Now, this and this go away. 2 to the negative 4th is really 1 over 2 to the 4th because he wasn't happy. So really it just says x minus 1 equals 1 over, what, 16? So this really is just x equal 1 over 16 plus 1. That's just 17/16. There it is. Wasn't that sweet? What was our strategy? We raised both sides to a power so that the left side gave us a 1 for a power. That was our strategy. Let's try this one. What would you have to raise both sides to give us 1? To give us just x minus 4? Well, the power is 2/3. His reciprocal is 3/2. Make sure you do it to both sides. Now, 2's cancel, 3's cancel. 1 to any power is easy because it's just 1. Ah, easy. Easy. Oh, but wait a minute. I lied to you. I lied to you. Think about what this means. This really means the square root of 1 cubed. Uh-oh. Tricky, tricky. Guys, when you have a square root, you potentially have a double root. A double root. Uh-oh. Because think about it. The square root of 1, well, it could be 1, or it could be -1. That's right. So that is actually what we're cubing here. Let me go back. When we take the square root of 1, you could get 1 or -1. And since we're cubing those, you could get two different answers. Because 1 cubed is 1, but -1 cubed is -1. So we actually have x minus 4 equal to both of these. And when you solve those, you get x could be 5 or x could be 3. And check those. If you plug them back in, you'll find that they both do in fact work. X could be 5 or 3. So be careful when you're taking those square roots and then cubing them, because multiple answers. How about letter D? How would you solve this one? This time, instead of a rational exponent, we have a variable exponent. So the variable is actually in the exponent. The variable is in the exponent. So my suggestion to you is to use the rewrite approach. The rewrite approach. Rewrite in terms of the same base. The same base. So what do I mean by that? I mean the left side is in terms of 2. You can't get much simpler than that. But the right side can be written in terms of 2. 512 is actually 2 to the 9th power. It's actually 2 to the 9th power. And guess what? When you have the same base on both sides, you can just kind of say, and there's only one of them, there's 1 2 on the left and 1 2 on the right, you can just say, bye-bye 2's, I don't need you anymore. All I care about are your exponents. So x was actually supposed to be, or actually is, 9. That's the value of x that makes it true. That only worked because we had the same base on both sides. Let's try one a little bit saltier here. Now, can we get everything in terms of the same base? And we can. 8 is really 2 cubed. Still raised to the x power, mind you. 2, can't get any simpler. But 4 is really 2 squared. Still raised to the 2x power. Power to a power means you need to multiply all these. Multiply all these. Multiply him. That's 2 to the 4x. Now, can we set the exponents equal yet? We cannot. We cannot, because there has to be 1 2 on the left and 1 2 on the right, but there's still 2 2's over there. But can you combine them so that there's only 1 2 over there? You can. Side by side means add them, add the powers. So now we got 1 2 on the left, see ya. 1 2 on the right, see ya. And what can you do with the exponents? Set them equal. So it's 3x equals 3 plus 4x. Take away 4x from both sides. Negative x equals 3. So x is -3. Love these. They're like puzzles that you have to use your different tools to figure out. Okay, what about this one? What can we do with this bad boy? Well, 81 and 1/9. Both of those, what numbers jumping out to you? What can you rewrite them in terms of? I'm thinking 81 and 9. I could rewrite them both in terms of a 9 or a 3. Doesn't matter. Why don't you go with the 3? So this is really 3 to the 4th power, but be careful. It's still raised to the x plus 2 power. All right, and here you have a power to a power, but actually what's happening here is you need to remember to distribute the 4 to the x and the 2. So it actually says 3 to the 4x plus 8 power. And on this side, this is really 1 over 3 squared. But if you want to deal with that power on the outside, the 3 minus x, you need to rewrite that as 3 to the -2nd power to the 3 minus x. Because now you can do the same thing we did on the left side. You can distribute. So it actually says 3 to the -6 plus 2x power. Okay, question. Do you have 1, 3 on the left? Yes or no? You do. Do you have 1, 3 on the right? You do. So say, see ya, 3s, don't need ya. I'm going to set your exponents equal, and I'm going to solve for the x, which is what I do need. So I would subtract 2x and subtract 8. So x is negative 7. Sweet. That's awesome. That is awesome. Okay. Oh, getting even saucier. Okay. 9, 27, 81. What's jumping out at you? I'm thinking 3. How about you guys? So 9 is really 3 squared. But remember, when you do power to a power, you got to give it to both of these guys. So it actually says 3 to the 2x plus 6. Okay? The bottom is really 3 to the 3x power. I'm taking a shortcut. I'm skipping the step where I write 3 to the 3 to the x. I think you guys know by now that you're supposed to multiply those powers. And on the right side, it'd be 3 to the 4th power. That's 81. This whole thing is square root. Now, this one's not so easy. You can't just cross them out. Can't just cross them out. Oh, but what can you do? We need to get rid of that square root. Now remember, to get rid of a square root, you simply square this side. But if you do that to the left side, you got to do it to the right side. Alright, sweet. Now how could I turn these 2 3's into 1 3? They're on top of each other. So do you add the powers or do you subtract the powers? Oh, that's right. You subtract the powers. Now make sure to combine like terms. 2x minus 3x is actually negative x. The plus 6 is still hanging out. And the right side will say 3 to the 8th power. Ah, so now I got a 3 on the left, a 3 on the right. Take the exponent. Say, bye-bye, 3s. Don't need you. I just need your exponents. Set them equal. X is equal to, oh, what is that? Take away 6 is 2, but make it negative 2. There we go. Okay, now this one's a little bit saltier. You don't have the nasty square root to deal with, but you do have x squared to deal with. All right, now 3 is on top of 3. On top of 3. So do you add the powers or subtract the powers? Oh, you subtract the powers. X squared minus x. Problem. They don't like each other. You cannot combine them. Alright, on the right side, it's 3 to the... and the best way to figure these out if you don't have them memorized is just start punching in numbers to your calculator. 3 to the 4th, 3 to the 5th, 3 to the 6th. And it's actually 3 to the 6th power. Well, I got 1 3 on the left. Bye-bye. A 3 on the right. Bye-bye. Now I have x squared minus x is equal to 6. How many answers am I going to get here? Oh, that's right. I'm going to get 2 answers, aren't I? Because it's a quadratic. And hopefully it factors. And it does. Factors to x minus 3 and x plus 2. Well, that means my answers are 3 and negative 2. Done. Alright, I guarantee you're going to have one like that in your homework. And I wouldn't be surprised to see something like that show up on a quiz. Okay, why don't you guys try this one? Okay, try your best at it. I would rewrite everything in terms of 2. Make sure you distribute the power. 32 is 2 to the 5th. That's 5x plus 10. 64 is 2 to the 6th. So that's actually 2 to the 6th x. And 16 is 2 to the 4th. This whole thing still has a square root. So pause the video and go ahead and try this one and see how you do. Okay, let's see how you did. I need to square both sides to get rid of that square root. And I'm going to go ahead and subtract these exponents because I have the same base on top and bottom. So it really says 2 to the negative x plus 10. On this side, power to a power means I multiply the powers. Bye-bye 2's. Negative x plus 10 is equal to 8. That means x is equal to positive 2. If you got that, give yourself a good old pat on your back. If you didn't get it, then just get it fixed real quick. No biggie. Before we go, I got one word problem for you. So read along with me. The price of firewood 4 years ago is $140 per cord. Per cord of firewood. Today a cord costs $182, so it's gone up. To the nearest whole percent, what's been the annual rate of increase? Rate of increase. Oh, as soon as I say rate, I need a formula that has an R in it. Does anybody know any formulas that have an R in it? Oh yeah, we had them in section 1. Does that look familiar? A of t equals a sub 0, or a initial, times the quantity 1 plus r to the t power. How did I know to put plus? Oh, because the rate is increasing. And what are we interested in here? We want to know the nearest percent that the rate has been. R is our question mark. We haven't had one of these. R is the question mark. Well, tell me everything I know. I know the initial amount. It's $140. Put it right there. Do I know the new amount? Yeah, it's 182. That's the new amount. Do I know the rate? No, but do I know how long it took to get there? Oh yeah, it says 4 years. That's t. So put a 4 here. So let's solve this for r. What you're going to do is divide by 140. 140 divided into 182. That's about 1.3. I don't know if it is exactly. Let me check that on the calculator real quick. 182 divided by 140. Yeah, it's 1.3 exactly. So that's 1 plus r to the 4th power. Now, here's the problem. The r is not in the exponent. The r is in the base. But I got to get rid of that exponent. I need to get rid of that 4. So you can either do two things. You can raise it to the 1/4 power, or you can take the 4th root of both sides. The 4th root of both sides. Either way of those works. If it was to the 10th power, you'd take the 10th root. If it was 17th power, you'd take the 17th root. So, on your calculator, type the 4th root of 1.3. 4th root of 1.3. And that answer is about 1.0678-ish. About 1.0678. That will equal 1 plus r. I just want to know r. So take away 1. So r is about 0.0678, which is about 6.78%, but it said to the nearest whole percent. That's about 7%. It's been going up by about 7% on a yearly basis. Sweet problem. Alright, that is all I got for part 2. I will catch you all later. I'm out.